Hi again. Last time, let's recall what we studied last time. We studied the limit of a complex function. So in that, we say that we choose some. So in z plane, and so we choose some region in that z plane. Let's say this was the region with z0 as the center and delta to be the radius of the disk. So we call this a delta disk, and we will have a corresponding region in the w plane, which is the f of z plane, and it has a center L and radius epsilon. So this is the epsilon disk, right? And we said that the limit exists for every f of z minus L, which is less than epsilon, for z minus z0, which is less than delta. So that means that for every z point which is within the disk, therefore we should get the difference to be less than the radius. If it would be outside, then the difference would be greater than delta. So when we put the condition that this difference, z minus z0 difference, is less than delta, it only means that the point will be within the region, and we should have a one-to-one relation. So for every point, every variable z, we should have a function f of z, a single valued function f of z, and which will lie in the w plane, and that will also satisfy the similar relation, that it will also be within the epsilon radius containing region. So it can't be outside this disk. So if this happens, then we say that the limit exists, f of z will tend to L when z will tend to z0. So we put a limit that when z tends to z0, the f of z will tend to L. This is how we define the limit. So this was just the recall that what we studied last time. Now we will move further from here, and today we will see one step ahead of this, and that is the continuity of the f of z. Once we have defined the limit for f of z, now we will see whether the f of z is continuous or not. So this is the next step we are going to see. And in this continuity, we define the alright. So let me tell you in a simpler way that the function f of z is continuous at z equals z0 if, when you take a limit of z tends to z0, the f of z itself become f of z0, right? So it is just like this, but we already defined the f of z0 to be L, means the center of this. If z tends to z0, we gave the name at the same point to be L, but in general we can say that if f of z corresponds to z, then f of z0 will correspond to z0, right? So that is how we define the continuity, that if a function w equals f of z is so a function w equals f of z is said to be continuous at z equals z0. So we define the function to be continuous at z equals z0 when or if it will be continuous at z equals z0 if the limit we define it to be z tends to z0, f of z will tend to f of z0. If this is satisfied, then we say that f of z is continuous at z equals z0. So this f of z0 is just the L. We just gave it a name equal to L. F of z0 we defined itself to be L. So it is almost a similar definition here. It is nothing new. So that is what I was saying, that if z corresponds to f of z, then z0 will correspond to f of z0, but we called it L. Okay, so it is very similar like we define limit. And one more point we should note here, that we defined f of z to be u plus iv, and more precisely it is uxy plus I vxy. So u is a function of xy and v is also a function of x and y. So this is how we define the f of z. Now if we say that if this f of z is continuous at z equals z0, so if this f of z is continuous at z equals z0, then the u and v will also be continuous at z equals z0. And we can define the same thing vice versa, that if u and v, both the parts are continuous at z equals z0, then f of z will also be continuous at z equals z0. Okay, so if w equals f of z equals u xy plus I v xy is continuous at z equals z0, then u and v are also continuous at z equals z0. And z equals z0, that means at x equals x0 and y equals y0. Okay, so from this we can write the converse sentence also, just like I said, that like I said, one second, like I said that if f of z is continuous at z equals z0, then u and v are also continuous at z equals z0. So the converse condition would be, if u and v both are continuous at z equals z0, that means w itself, or the f of z, will also be continuous at z equals z0. So that is the converse statement, that if u of xy and v of xy are continuous at x0 y0, then f of z will also be continuous at z equals z0. So this is how we defined the continuity of function f of z.